So let's see how to write one of these structures. So this is one of our glucose structure. I'm not writing it vertically, I'm writing it horizontally. Okay, so C double bond OH, H, OH, H, OH, H, 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 OH, OH, CH2, OH. Okay, so there are totally 6 carbon atoms with 4 chiral carbons. Okay, so now this horizontal chain will get folded into a 6-membered ring. So what I'm going to do now is I'm going to fold the horizontal carbon chain into a hexagon. Okay, so with 1, 2, 3, 4, 5, 6. I'm going to draw a 6-membered ring. Out of the 6 corners of the ring, 1 corner is oxygen. The others are all, out of the 6 vertices of the ring, 1 vertex is oxygen, the rest are all carbons. So this is what the ring is going to look like. Okay, and this vertex is oxygen, which is this oxygen right here. Okay, and the rest of the molecule as is. Okay, so remember, we're showing that this hydroxide is reacting with this carbonyl compound to form a hemiacetal. When a hemiacetal is formed, remember, this becomes the OH, right? So then H, H, OH, OH, H, H, OH, and of course this one has a H and CH2OH, and so this is your hemiacetal. Okay, this is the cyclic hemiacetal structure. Okay, now remember, this is a new formation. It was a double bond O before, and now it became a OH. So now this OH has a choice. It can go above the plane. Okay, just to make it clear for you what is above and what is below, I'm just going to draw this as a thick line, and I will show you the models in the classroom. Okay, so this OH can go above the plane to form a beta form. Okay, or it can go below. So this is the beta form, or it can go below the plane to form the alpha. Okay, so this has a choice. It can go above or below the plane of the structures. So this alpha form and beta form are 2 stereoisomers. Okay, and this type of stereoisomerism is known as anomerism. So these isomers are known as anomers. So this is alpha anomer of D-glucose. So alpha D-glucose, and the previous one was beta D-glucose. Okay, so we introduce another term, anomer, here. Okay, so think about this. There is the open chain D-glucose. I'm not drawing the structures, I'm just representing them with letters. Open chain, okay, which is, like this. Okay, it has not formed the hemiacetal yet, so open chain, right? And then in solution, okay, in solution, what happens is that the hemiacetal structure of, let's say, alpha D glucose, right? Alpha D glucose. So the alpha anomer form. Okay. In solution, it opens up. In solution, it opens up, okay, to form open chain like this. But the carbonyl group and the OH group are so reactive that they right away react to form anomer. Now, when they form the anomer, they can form the beta anomer or the alpha anomer like we talked about before. So basically what happens, you take the beta D glucose, put it in aqueous solution, opens up, then it forms beta or alpha anomer. Then it opens up again, then it forms beta or alpha anomer. So this ring opens and closes, keeps on opening and closing. So in solution, roughly at equilibrium, there is 36% of alpha and 64% of beta form. And this opening and closing of this, or the formation of alpha and beta anomers, is known as mutarotation. Mutarotation.